Hello guys, welcome to my channel. My name is Naus and today I'm going to teach friction and what friction is. So basically what friction is, anything that opposes a relative motion of a body is friction. So suppose this is a car and this is moving in this direction, the forward direction. So the car is moving and a friction force will act on this direction. Due to this friction, the car is moving in this direction. Or you can say, as the car is moving in this direction, there is a frictional force acting backward of this direction. So this is what friction is. It's opposing a motion of a relative motion of a body. So friction can also be classified into various types, actually two types. So that is static and kinetic friction. Static friction is a friction, the friction which acts on a body that is static or that is on rest. Suppose a frictional or the static friction, you can say it has a tendency to move. The body which has a tendency to move, that's where the static friction acts. Suppose I can give an example that this is a ball and this is me or a boy pushing this ball here. So the ball is pushing the ball and the ball is not moving. Due to the static friction, the ball is not moving because the frictional force is acting on the surface, on the ground surface of the ball. So this is a clear example of static friction. So now, what is kinetic friction? Kinetic friction is a friction which acts on a moving body. Or you can say, the example that I have given, the car example previously, the car is moving in this direction and the frictional force is acting in this direction. So this is an example of kinetic friction. A moving body, and in that moving body, a frictional force is acting. This is kinetic friction. The word kinetics is defined for a moving object. So that's why we are using, that's why this means kinetic friction. Now similarly, kinetic friction can also be classified into three types. That is viscous, sliding, rolling friction. So sliding and rolling friction acts on a body. However, the viscous friction is clearly defined for viscous objects or viscous body that is liquid. This happens due to the different velocities or layers of liquid. And static and sliding also occurs because of this, normally because of friction. If a body slides on an object, that's where sliding friction acts. And if similarly, if a body rolls, a cylindrical body or spherical body rolls on an object, this is where rolling friction is. So now, friction. This is the formula of friction. F is the frictional force, mu is the coefficient of friction. Mu is the coefficient of friction. What is coefficient of friction? Coefficient of friction is a constant that is defined, that is used to measure the friction of two bodies. And this is normal force. Normal force is a reaction force that acts on a body. This is normal force. And this normal force is acting because of the mg acting on it. So normal force is a reactive force. The reactive force is a normal force. That's where I'm going to multiply with the coefficient. So now, let me give you an example. So this is an object of weight, so let's suppose of mass gram, and here there is an angle theta. So we are going to draw the free body diagram of this project. So what is free body diagram? Free body diagram is a rough diagram that is drawn to define all the forces acting on that body. So we are going to define the free body diagram of the small mass m that's on the object on the slide that have an angle theta. So as you can see, this is mg, the weight of the body, the weight which is equal to mg. So As the body will move this direction, where will the friction force act? The frictional force will act this way. This is friction force. This is friction force. The normal force will be there. This is normal force. Now to draw this in the x-axis and x and y-axis, we can do one thing. We can make component of mg, like this is mg sine theta, and this is mg cos theta. As this is 90, this is 90 minus theta, so this will be mg sine theta. Okay, so here you can see normal force is mg cos theta. As I have already told you, that normal is a reactive force. So anything that's acting on the body, this direction, that will cause the normal force. Normal force, here the normal force is mg cos theta. And so the friction will be mu n, that is, here suppose in that surface, the frictional coefficient is mu. So friction will be mu n, that is mu mg cos theta. So this is how we derive the formula, or this is how we solve a question for friction, a free body diagram of frictional force. Now, there are two types of friction as I have already discussed. One is static friction and one is kinetic friction. So, coefficient of friction can also be classified as coefficient of limiting friction and coefficient of kinetic friction. The question is, where do we apply coefficient of limiting friction and coefficient of kinetic friction? Coefficient of limiting friction is applied when the body is not moving or is at static. Then we apply coefficient of limiting friction. And coefficient of kinetic friction is applied. We apply this coefficient of kinetic friction when the body is in motion or kinetics. Okay. So this is where we apply coefficient of kinetic friction, coefficient of limiting friction. Always remember the point that coefficient of limiting friction is always greater than the coefficient of kinetic friction. Why it is? Because if a body is at rest and a force is applied, the frictional force is applied here, the frictional force is applied here. So when the frictional force will cross this coefficient of limiting friction, then only the body can move in the direction of this direction. The moment it crosses this direction, and the frictional force will change it, and it will change to coefficient of kinetic friction. That is, its body is moving this direction, force is applied this direction, frictional force is there, where we use coefficient of limiting friction. So the moment the body is moving, we are using coefficient of kinetic friction. At the moment the body has a tendency to move, and the force is just crossing the friction, then we are using coefficient of limiting friction. Okay, so now so you can see this question. So let's see, here the body is at rest, and we have to find the coefficient of friction. Okay, so as you can see, the weight of the body is given 150 Newton. And a force is applied in the right foot horizontal direction, that is 50 Newton. So let's draw the free body diagram of the body. I have already discussed what is free body diagram. So here I am drawing the free body diagram. So weight is acting in this here, 150 Newton. So a reactive normal force will be applied just in the opposite direction of the weight, that is normal reaction. And as the force is applied in this direction, that is 50 Newton, there will be an opposite friction. That is that. Now, here the thing is, as it's mentioned, the body is at rest. So, as it is at rest, the directional force, that is fx direction, the total force in the x direction should be equal to 0. Then only the body will be at equilibrium. The equilibrium means all the direction forces is 0 and the body is at rest. So, only if force F is equal to F, that is equal to 50 Newton, then only the body will get rest. Because in this direction the force is there and in this direction the force is there, then only the body can attain rest at the horizontal direction. And at the vertical direction is already at rest because the 150 Newton is balanced by the normal interaction. Okay, so let's solve the question. So as I have already discussed that F is equal to 50 Newton, which is equal to F, and here F is equal to mu of n. Here we have to find the mu. The mu here, mu is limiting mu because the body is at rest. So as I have already said, so here's Q is mu and the normal is given. Normally it will be normally it will be equal to 150 Newton. That is mu into 150 is equal to 50. Mu is equal to 50 by 150. That is equal to 1 by 3. That is equal to 0.33. That is mu. So this is it for our today's class. We have covered friction, types of friction, what is friction, and how we have solved the questions of friction, limiting friction, and kinetic friction. So in the next chapter, in the next video, we'll discuss more about friction. Thank you so much.